Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series JEE-Advanced TEST-6A Paper 1 that was held on 28th April 2019. So let us start with the question number 41, in which we have to find the value of the limit n tending to infinity 2ncn whole raised to the power 1 by n. Let us assume the given limit equal to L. So we can write L equal to limit n tending to infinity 2n cn whole raised to the power 1 by n. If we take log on both sides, so we can write log L equal to limit n tending to infinity. Taking log 1 by n can be taken out, so I can directly write 1 by n into log of, if we expand 2n cn, then we will get n plus 1 n plus 2 and so on up to 2n, that is n plus n upon 1 into 2 into 3 and up till n, right? So further this can be written equal to limit n tending to infinity 1 by n into log of, now this can further be written equal to n plus 1 upon 1, that is 1 plus n by 1 into 1 plus n by 2 and so on up till 1 plus n by n. So it can be observed that it is equal to limit n tending to infinity 1 by n into summation of r equal to 1 to n log of 1 plus n by r, right? R is going from 1 to n. So it can be written equal to integration of log of 1 plus 1 by x into dx, where x is going from 0 to 1. So this is the value of log L. Now this can be calculated very easily, solving it by parts. So this is equal to log of 1 plus 1 by x into x minus integration of x into minus 1 by x square divided by 1 plus 1 by x into dx. So this can further be written equal to, here the limit is from 0 to 1, so we will get log 2 plus integral of 1 by x plus 1 into dx, where the integral is going from 0 to 1. So this is further equal to log 2 plus its integration will be equal to ln mod x plus 1, where the limit is going from 0 to 1. So this is equal to log 2 plus log 2, that can be written as 2 times log 2. So this is equal to log 4. So we have log L equal to log 4. So we can say that the value of limit L is equal to 4. So its answer will be 4. Now let's move on to the next question, that is question number 42, which says that the value of integral 0 to pi by 2 x cos x plus 1 into e raised to the power sin x dx. We have to find its greatest integer, right? So basically, firstly let's find the value of the integral from 0 to pi by 2 x cos x into e raised to the power sin x into dx. Let us split it into two integrals, plus 0 to pi by 2 e raised to the power sin x into dx. Let us firstly find the value of these two integrals. Now let us apply by parts on the first integral. Let this be one function and this be other. So we can say that integral of cos x into e raised to the power sin x dx, its integral will be equal to e raised to the power sin x itself, right? So it can be written equal to x into e raised to the power sin x minus integration of 1 into e raised to the power sin x into dx from 0 to pi by 2. And we also have the second integral, that is also the same, e raised to the power sin x into dx. So this can be observed that both of these can get cancelled. So directly our integral will be equal to x into e raised to the power sin x, where the limit is going from 0 to pi by 2. So this is equal to pi by 2 into e raised to the power sine pi by 2, that is e minus 0. So we have to find the greatest integer value of e into pi upon 2. So this will be equal to, putting the value of e and pi as 2.71 and 3.14 respectively. So we will find the value equal to 4. So its answer will be 4. Let's now move on to the next question, that is question number 43, which says that if the equation of the plane which passes through the intersection of the planes x minus y plus z minus 3 equal to 0 and x minus 2y minus 3z equal to 0, and it have been given that it is parallel to the plane x plus y plus 9z plus 3 equal to 0. Now such plane is given to be equal to ax plus y plus bz plus c equal to 0. So we have to find the value of a plus b plus c. Now it have been given that the plane is passing through this plane, let us say it is P1, and this plane, let us say it is P2. So our required plane passes through the intersection of the planes. So we can assume the plane to be equal to P1 plus lambda P2 equal to 0, right? That is x minus y plus z minus 3 plus lambda times x minus 2y minus 3z equal to 0. So we can see that the coefficient of x is 1 plus lambda plus coefficient of y is minus 1 minus 2 lambda plus coefficient of z is 1 minus 3 lambda minus 3 is equal to 0. This is our required plane. Now it has been given that it is parallel to this plane, that is P3. As it is parallel to P3, so we can say that the coefficients of x, y and z will be in proportion, right? So we will write 1 plus lambda upon 1 is equal to minus 1 minus 2 lambda upon 1 is equal to 1 minus 3 lambda upon 9. So this is the relation that we get. So taking first and second, we will get 3 lambda equal to minus 2. That is the value of lambda is equal to minus 2 by 3. Now putting back the value of lambda in equation 1, we will get the required equation of plane as x into 1 minus 2 by 3, that is 1 by 3, plus y into minus 1 minus 2 times lambda, that is plus 4 by 3, plus z times 1 plus 2 minus 3 equal to 0. That is the equation is x by 3 plus y by 3 plus 3z minus 3 equal to 0. Now in the given equation of plane, the coefficient of y is 1. So we will write x plus y plus 9z minus 9 equal to 0. So comparing it with the given equation, we can say that value of a is equal to 1, value of b is equal to 9 and the value of c is minus 9. So we can say that the value of a plus b plus c will be equal to 1. So required answer is 1. Let's now move on to the next question, that is question number 44, which says that consider all 6-digit numbers of the form ABC, ABC, where A, B and C are not necessarily distinct. If the number of all such 6-digit numbers that are divisible by 7 is n, then the sum of digits of n is, right? We have to find the number of such 6-digit numbers which are divisible by 7. Now the number ABC, ABC, it can be written equal to 10 raised to the power 5 into A plus 10 raised to the power 4 into B plus 10 raised to the power C 3 into C plus 10 raised to the power 2 into A plus 10B plus C. This is how we can write the number. Now here it can be seen that if I take A common from here, rather 10 raised to the power 2A common from here, so we'll get 10 raised to the power 3 plus 1. Similarly from this and this one, let us take 10B common, so we'll get 10 raised to the power 3 plus 1. Similarly from this and this term, let us write it equal to taking C common, 10 raised to the power 3 plus 1. So here it can be seen that this is equal to 10 raised to the power 3 plus 1 can be taken common from all. So we will be left with 100A plus 10B plus C. Now here, if I look at this number, this is 1001. Now it can be seen that it is divisible by 7, which means that any such number is divisible by 7. We just have to find all 6-digit numbers of the form ABC ABC. Now here it can be seen that A can take any number from 1 to 9, so it have 9 possibilities. Similarly, B can take any number from 0 to 9, so it have 10 possibilities. Similarly, C will also have 10 possibilities. So we have in total 900 such numbers, but here we have to find the sum of the digits of n. Sum of the digits of n is 9 plus 0 plus 0, that is 9. So answer of this question will be 9. Next, let's move on to question number 45, which says that a circle touches the y-axis and it also touches the parabola y square equal to 4x at 1, minus 2. If the radius of the circle is a minus root b, where a and b are natural numbers, then the value of a minus b is. Let us make the diagram first. This is the curve y square equal to 4x, and it have been given that there is a circle which is touching y-axis and it is also touching the parabola. So let us say this is the circle and this point is 1, minus 2, right? So it can be seen that if I draw the equation of normal at 1, minus 2, then it will be passing through the center of the circle. So let us firstly find the equation of the normal at 1, minus 2. Now the given curve is y square equal to 4x. So differentiating it, we will get 2y into y dash equal to 4. That is, y dash is equal to 2 by y. This is the slope of the tangent. So the slope of the normal will be equal to minus y by 2. Now at y equal to minus 2, the slope will be 1, right? So the equation of the normal will be y plus 2 equal to 1 into x minus 1. That is, x minus y minus 3 equal to 0. This is the equation of normal. Now if I assume the center of the circle as r, comma. Now from here, if x is r, so the value of y will be r minus 3. Now it can be observed that the circle is touching y-axis, which means that the radius of the circle will be equal to x coordinate of the center. So its radius is also r. So we can say that this distance, let us say AB is equal to r. So let us apply distance formula here, because we know the point A, that is r, r minus 3. So let us apply distance formula here. We can say that r minus 1 whole square plus r minus 1 whole square is equal to r. That is 2 times r minus 1 whole square is equal to r square. So solving this further, we will get r square plus 1 minus 2r minus r square equal to 0. That is r square minus 4r plus 2 equal to 0. So we can say that the value of r will be equal to 4 plus minus under root of 16 minus 8, that is under root 8 upon 2, that is the value of r is equal to 2 plus minus root 2. Now it can be observed from the diagram that the radius will be less than 1. So required radius will be equal to 2 minus root 2. Now it have been given to be equal to a minus root b. So we can say that the value of a is equal to 2 and the value of b is equal to 2. So the value of a minus b will be equal to 0. So we can say that the required answer will be 0. Next is question number 46, which says that if the area bounded by the curve sine square x plus sine square y equal to 1, where x and y both are going from minus pi by 2 to pi by 2 is a square units, then we have to find the value of 10a upon pi square. Now we can write sine square y equal to 1 minus sine square x, that is cos square x. So we have to find the area bounded by sin y equal to plus minus cos x, that is y equal to plus minus sin inverse cos x. Now this can further be written as plus minus pi by 2 minus cos inverse cos x. Now students, we know the graph of cos inverse cos x. So by transformation of graphs, we can draw the diagram of y equal to plus minus pi by 2 minus cos inverse cos x. And here it have also been given that x and y both are going from minus pi by 2 to pi by 2. So in between that, we will get the graph as this one, where these points are pi by 2 comma 0, 0 comma pi by 2, minus pi by 2 comma 0, and this is 0 comma minus pi by 2. Now we just have to find the area bounded by this. So its area will be equal to 4 times area of this triangle, that is half into pi by 2 into pi by 2, that is pi square upon 4. So this is equal to pi square upon 2. So value of 10 into pi square upon 2 pi square will be equal to 5. So answer of this question is 5. Next is question number 47, which says that if the value of integral from 0 to pi by 2 dx upon 1 minus tan square x is lambda pi upon 16 square units, then we have to find the value of lambda. So students, it can be observed here that the graph is discontinuous at x equal to pi by 4. So we have to break the function at x equal to pi by 4. So we have to find two integrals here, that is 0 to pi by 4 dx upon 1 minus tan square x plus integral from pi by 4 to pi by 2 dx upon 1 minus tan square x. We have to find these integrals. Now here let us put x equal to t plus pi by 4. So we will get it equal to integral when x is 0, then t is minus pi by 4, and when x is pi by 4, then it is 0 dt upon 1 minus tan square t plus pi by 4. Similarly, here we will get the integral from 0 to pi by 4 dt upon 1 minus tan square t plus pi by 4. Now here separately, let us firstly find the value of the integral dt upon 1 minus tan square t plus pi by 4. Now we know the formula of tan of a plus b, so we will write it equal to dt upon 1 minus tan of a plus b is tan a plus tan b upon 1 minus tan a tan b, and we have square on it. So this is further equal to dt into 1 minus tan t whole square, and in denominator we will have minus 2 tan t, that is minus 4 times tan t. So this is further equal to integral 1 plus tan square t minus 2 times tan t into dt, and in the denominator we have minus 4 times tan t. So this can be written equal to, if I take minus 1 by 4 common, so we will get secant square t minus 2 tan t into dt upon tan t. So let us directly write it here, that is, it is equal to integral from minus pi by 4 to 0 minus 1 by 4 into secant square t upon tan t into dt plus integral from minus pi by 4 to 0, taking the next term, that is minus 1 by 4 into minus 2, that is 1 by 2 into dt. Similarly, here also we will get two terms, that is from 0 to pi by 4 minus 1 by 4 into secant square t upon tan t into dt plus 0 to pi by 4 1 by 2 into dt. Now if we talk about the function that is secant square t upon tan t, as the function is odd function, so we can say that the integral from minus pi by 4 to 0 will be equal to negative of the integral from 0 to pi by 4. So these two integrals can directly be cancelled. Further, we can see that these two are continuous, so we can directly write it equal to half into integral of dt, that is t from minus pi by 4 to pi by 4. So we will get 2 times pi by 4, that is pi by 2. So this is equal to pi by 4. Now it have been given in question to be equal to lambda pi upon 16. So the value of lambda will be equal to 4. So this is the answer of this question. I hope the question is clear to you. Next, let's discuss question number 48, which says that consider a function fx equal to sine inverse pi ln cos inverse x by 3. Then we have to find the number of integers belonging to the range of fx. Now, we know that cos inverse x by 3, its range is from 0 to pi. So we can say that ln of cos inverse x by 3, it will go from ln 0, that is tending to minus infinity, up till ln pi. Now, multiplying by pi, we will get pi into ln of cos inverse x by 3. It will go from minus infinity to pi times ln pi. Now, applying sine inverse, we can see that sine inverse of pi into ln of cos inverse x by 3. Now, its maximum limit is minus pi by 2 to pi by 2. So, it will go from minus pi by 2 to pi by 2. So, this is the range of the function. So, number of integers belonging to the range of fx will be minus 1, 0 and 1. That is, we have 3 integers. So, the answer will be 3.